Hello, welcome back. So, determining oxidation states or oxidation numbers, these, right, what they represent are the possible charges for an element. And the place that you find them are over here on the reference table, selected oxidation states, right? So carbon has three possible oxidation states. There are three ways that you could possibly charge carbon. Carbon could be a -4, carbon could be a +2, and carbon could be a +4, right? It will never be all three at once. It will be one or the other. Now carbon is what I would consider a bad example for this because there are options. There are many elements on the periodic table that are fixed. They must be a specific thing. If I were to look over here at magnesium, it has to be a +2. Calcium has to be a +2. If I look at lithium, it has to be a +1. It has no other choice. What you should notice, I don't know what that, I didn't want to do that. There we go. What you should notice is that generally these metals, if you look at any of them, most of them, all of them, they have positive charges. Right? The metal will typically be positively charged. The nonmetals, even though some of them have like secondary, you should notice that like the second and third or maybe the fourth are positive. The first one that shows up for most of the nonmetals is negative. That is intentional. Nitrogen is a complete nightmare. I will almost never ask about nitrogen. The Regents almost never ask about nitrogen. However, when you have to figure out, when you have to go backwards, right, we talked about these are the ions, form the compound. Now what we're going to do is we're going to look at a compound and say, what are the ions that make it up? So we're going to go a little back and forth. I'm going to focus more here. You should have your reference table. I know most of these oxidation states off the top of my head. Now, in this example, we use H2SO3. Right. So find the oxidation state for S. Find the charge of S. The problem is right here. S has more than one choice for the oxidation state. If you're asked a question like this, find the oxidation state for S in this thing, and you look, you check your reference table, and you're like, S. It has 3. What I do not want you to do is guess. Please do not just guess. You can find it with complete certainty. You can find it and be like, I know that this is right. Right. So the way that you're going to do it, you're going to look back here. We can use the oxidation states for hydrogen and oxygen to help us figure it out. And the reason we can do that is because we know everything is neutral. So if we add them all together, they have to add up to 0. Right? So here's what I'm going to look at. I'm going to move off to the side a little bit here. I know that it's explained right there, but I'm going to do it. I'm going to do it in a thinner pen here. So H2SO3. Right? I'm going to look at these other guys. Now, as a little hint, and I didn't talk about this with the ionic compounds, but you might want to, let's very quickly go back up. Or over, I guess. It's over here? Okay. With the ionic compound. Right. Positive ion is always first. The positive ion always comes first in an ionic compound. And I'm bringing that up intentionally when we're talking about oxidation states here, but I try to write that down. And if you don't have it written down right now, I'll try to make sure that we have it written down in class when we come back to this, when we do these examples, when I look at them. The positive ion always comes first. And that's particularly relevant here because if I check my reference table and I go up to table E, which right now is sideways, I'm pretty sure I'm going to have to rotate this 3 times because I don't know how to rotate counterclockwise. That's okay. I look right here. SO3. Look, that's a polyatomic ion. And this compound has SO3. So this compound is ionic, which means the first part of this has to be positive. That's actually very important. That's very important because if I go back to my reference table and I go back to the periodic table and I rotate again, I will find that H has two possibilities. It could be positive or negative. Because H is at the beginning here, it's going to be positive. So that means I have an H plus 1 and an H plus 1, right? I have two of these hydrogens. They are both H plus 1s. That means I have a total positive here of plus 2. Sulfur, we said, well, I don't know. Let's skip it for now. Let's look at oxygen. Oxygen has an oxidation state right over here of -2. It can only ever be -2. So, let's label it. That means I have 3 of them. So I have oxygen with a -2, and oxygen with a -2, and oxygen with a -2. So that means I have a total -2, -2, -2, or -2 times 3. Right? It's a total of -6. So I have +2, -6. I don't know the charge on this sulfur, so I'm going to call it X. Well, here's the thing. I know that it all has to add up to 0. So 2 plus X minus 6 has to equal 0. Right? So when I do this, right, if I have to solve for X, this is like saying if I subtract 2 from both sides and add 6 to both sides. So let me subtract 2 from both sides first. This says X minus 6 equals -2. That means that X equals 4. And if you look, that's the same thing that we got over here. So I know that the charge on sulfur must be +4. Now let's double check. Does sulfur have a +4 oxidation state? It totally does. Look right here. X has a +4 oxidation state. So that worked. All right. Now, 98% of the time, again, you'll be dealing with a compound, so what you will add up to is 0. There's a very important bullet point here, which says for a polyatomic ion, the oxidation states, the charges will not add up to 0. They will add up to that number that's in the top left. So for most of these examples, for 1, 2, 3 of these examples, right, the oxidation number, the oxidation states are all going to add up to 0, just like they did here. But for these bottom two, they're not going to add up to 0. They're going to add up to whatever number is in the top left here. All right? The practice is to find the oxidation number, find the oxidation state for everything in here. So what is the oxidation state for sodium? What is the oxidation state for chromium? What is the oxidation state for oxygen? Right? And what I mean by that is don't give me what the total charge is. Give me what, like, individually, what would they be, right? Each of these H's is a +1. Each of these oxygens is a -2. So when you do these questions, keep that in mind. Spoilers, anytime you see an oxygen, literally all of these oxygens are going to be -2. That's the only option that you have. All right? Use that information. Use the information that has to be a certain way to figure out the other stuff. All right? Also keep in mind what I asked you to write in back here, which is that the positive ion always comes first. Spoilers, these are all ionic compounds, so the first thing in each of these is going to be positive. Just has to be. All right? Now, we will go over these first thing on C Day. And then we'll continue talking about how to make these and how, specifically, actually, the next thing we're going to do is how to name these, right? But, until next time, until C Day, take care of yourselves, kids. I'll see you around.